Hello friends, in this lecture we are going to learn a very important topic of analysis and design of algorithm, minimum spanning tree, and we are taking an algorithm of minimum spanning tree is Kruskal algorithm. Minimum spanning tree is actually a spanning tree in which the weight of the sum of the edges should be minimum. You will include all those edges of a particular graph which minimize the weight of the overall graph. So we'll follow the algorithm by taking an example. First of all, you have to create a data structure over here. I am taking a variable name A, which is initially empty. So you will take a variable A, which is initially empty. Okay, we don't have anything in this particular data structure. So after that, we have to take each vertex that belongs to the vertices of graph. We have to make set. That means we have to consider each and every vertex of the graph. Then after that, sort the edge weights in increasing order. That means if we'll take this particular example, so in this you can see this is an undirected graph, and in this graph we are having a number of weights which has been given on each and every edge. So first of all, we'll sort this in the increasing order of their weight. Like this, we can also write it down over here. 1, we have been given 1, 4, 5, 6, 5, 6, 10, 11, 12, 13 and 20. After that, we'll start taking each and every vertex of this particular graph. Then we'll start by taking each and every vertex in the increasing order of their weights. So for each edge uv, find set of u should not be equal to find set of v. That means both of the vertices weights should not create a cycle according to this step, and will include all those vertices with the edge in between them in the data structure which we have created initially. So started by doing it. First we can see here that the first edge weight is 1. So if we'll include this particular vertex C and E by having a weight 1 over here, then you can see that this is the first edge in the complete graph. So this is not creating any kind of cycle. So we have taken C and E vertex with an edge weight of 1. After that, we can take another weight, that is 4. So if we'll take a 4 over here, then in this 4 vertex, and vertex A is included. So we can also include that because still it is not creating any kind of cycle. Then after that, if you can look at this sorted edge, we have included 1, we have included 4. We can take another weight which is 5. So if we look at 5 in this graph, so 5 is from C to D. We can include 5 over here. 5 we can add it over here. 4, 5 and 1. Still it is not creating any kind of cycle. Then after that, if we can include 6, check that if we can include 6 or not. If we'll include 6 over here, then you can see if we add a edge over here, then it will create a cycle. So we cannot include 6. We'll cross it over here. Then after that, we can check for 10 because the next increasing weight is 10. So we can check for 10. Again, if we are adding 10 over here, then it will again create a cycle between A, D and C and E. So we'll not include 10 over here. Then after that, we'll try to include the next vertex, which is 11. So if we'll include 11 over here, then it is not creating any kind of cycle because it is taking a newly created vertex, and we can add it over here 11. So we can add 11. Then after that, we can check it for 12. We can check 12, and 12 is, if we can check 12, 12 is F. So F we can add over here, and F12 weight is 12. So after that, you can check that you cannot add anything else because all the edges if we include it will create a cycle. So we can add all those vertices which we have tick mark over there and added over there is adding in the data structure U, and this is the end of the Kruskal algorithm. Thank you.